Okay, so in this video, we're going to be going through some examples of trying to determine when we don't have a subspace. What I'm going to recommend is if you feel comfortable with the idea of writing things as the span of vectors, that you try these as much on your own as you can, and then kind of come back here just to see the solutions. If you're not comfortable yet with this idea of subspaces and with writing things as a spanning set, then what you'll want to do is kind of maybe watch some, and then when you think you've got the idea, pause and try the next one, and then go from there. All right, so we want to know which of these is a subspace, and if it is a subspace, we're going to write the set as a span, if it is. And if it's not, we're going to show a condition that fails. So let me give us a little bit of practice. If we look at this first one, we have the set of all A, 0, 0, B, 2 by 2 matrices where A and B are real numbers. So remember, we can think of this as being A times 1, 0, 0, 0 plus B times 0, 0, 0, 1, where A and B are real numbers. And so this is our definition for the span of 1, 0, 0, 0 and 0, 0, 0, 1. So it's the span of those two vectors. So that's one way to do things. The other way to do things is going to be to go ahead and check all three properties. So I'm doing this properties one just to see that we can do it either way, but also because I want to get kind of a little bit of an extra demonstration of showing the three properties, because if it's not a subspace, you have to show which property won't end up working. Okay, so the first property is that the 0 vector, in this case the 2 by 2 0 matrix, is an A. Well, is it? 0 there, 0 there, 0 in those other places. Yep, that works. If we have 0 or alpha times some A 0, 0, B, we'll get alpha A, 0, 0, alpha B. And so notice that that means we have kind of two different things here. These are zeros, so this satisfies our A. And then last but not least, if we have some sort of A1, 0, 0, B1 plus A2, 0, 0, B2, then what we'll get is A1 plus A2, 0, 0, B1 plus B2. And so notice that this has zeros in the top right and the bottom left, and real values in the top left and the bottom right. And so this is in A as well. So A is a subspace of M 2 by 2. Okay, so that's A. We got three more of these. So let's take a look at B then. So for B, we say that we have A0, C, B, where A minus 2B equals 0, and C is an element of the real numbers. Well, what we're going to do is, since we have a condition here, we want to take and rewrite our condition to be A equals 2B. And if we do this substitution, we'll get that we have the set of all 2B, 0, C, B, such that B and C are in the real numbers. So note we took the restriction off of B, so we're just allowed to say, okay, it's not unrestricted, it's in the real numbers now. And so this, breaking it apart into what our different constants are here, we have B times the vector 2, 0, 0, 1, plus C times the vector 0, 0, 1, 0, such that B and C are in the real numbers. And so this is the span of 2, 0, 0, 1 and 0, 0, 1, 0. So because we can write it as the span of vectors, B is a subspace of M 2 by 2. All right, 2 down, 2 to go. Let's now take a look at the set C. So here we have that C equals A0, C0, where A plus B equals 0. Well, if we wanted to rewrite this, that'll be that A equals 1 minus C. Or we could write it as C equals 1 minus A. Doesn't really matter. And what we'll get is A0, write that. What we'll get is 1 minus C, 0, C, 0, such that C is an element of the real numbers. Okay. Now, it doesn't look like we're going to be able to take this one part here and write it as a span, so we need to check whether or not our conditions are satisfied. So here, we have 0, 0, 0, 0, and we want to know if that's part of C. Well, if you'll notice, if C equals 0, then 1, 0, 0, 0 is part of C. And if C is 1, then we get 0 for the top left entry, but we have 1 down here. And this is part of C. So no, the 0 vector is not in C. So since the 0 vector is not in C, C is not a subspace of M 2 by 2. All right. Last but not least, we have one more. We have this set D, which is A1, 0B, where A and B are real numbers. So let's ask the question, is the 0 vector here going to be an element of D? Well, the answer to that question, based on the fact that there always has to be one up here, is no. So, since the 0 vector is not in C, C is not a subspace of M 2 by 2. Sorry, we're talking about D now. Since it's not in D, D is not a subspace of M 2 by 2. So most of the time when you're looking for which property is going to fail, if it can't be written as a span, it'll be the 0 vector. Every once in a long stretch, the 0 vector on its own won't work, and so you'll need the other two properties, but it's not going to come up all that often in this class.